We're live. Speak, Oliver. Say something. Just give me a second. Alright. Nice. Okay, so today we're programming the Basalt Deltas. If you're wondering why I'm in a void of eternal nothingness, so today we're going to be programming the Basalt Deltas. So you can see here, these are the Basalt Deltas in Minecraft, right? If you compare them to the rest of the terrain, they're comparatively very bumpy. They're not smooth at all. They're basically, they look completely different, and they sort of are. So we're going to be talking about how we're going to do this. So everything that you see here is from a like the reason why it isn't smooth, right, is from a subset of generation called futures. Futures are what let you do not quite structures, but still structurized placement. I guess that's a good way to describe it. Like, for example, these pillars right here, these are futures. These are called basalt pillars. These are called basalt columns. And one of these things is called delta. I forget which one, but that's what we're starting out with. We're doing deltas. So, yeah, if you don't know what we're doing this, my fucking mouse. I have to, like, hit it so that it clicks. No, you missed one. Alright, that's good. So we're doing this in the Nether Star project. If you don't know, the Nether Star, it is my project with the goal of taking a airship to the world border through the Nether, through the terrain, instead of above it. And so I needed to build a very accurate pathfinder, which means I needed to build a very accurate procedural generator. Oh my god, you're so quirky. Hold on. Sway likes to do this. Okay. So this is what we have so far. We have the pillars and the biomes and the surface rule. And we can actually look here. If I go to draw.io, that's the wrong one. This is all that we have done right here, which is a lot. So I'm going to be doing something wrong. So we have pretty much everything that we need to be done except for futures. That isn't quite true. There is some stuff that we still have to do scattered about the place. For example, structures. We still have to do some bounding boxes, particularly with the what's it called, the Bastion Remnant. And then I'm gonna remake the Nether portal, the ruin portal, because I now know how the randomness works there, and I can easily recreate it. Before I was just putting a bounding box. If we're on these purple voxels are what the game refers to as something. Literally, they just are indicating that a structure is there. In this case, these are all fossils. You can see here we have this thing right here. We go in game. I believe that's over here. You can actually see the coordinates: 44387. If you're wondering how I got the performance, I believe I did. No, I didn't do a stream on that. That was a TikTok thing. Okay, so here it is. Here it is. You can see that they are literally just very similar. Interestingly, these are not similar over here. They're actually different, which I'm not exactly sure why, but it's pretty much the same everywhere else. And you may notice, like, oh my god, there's a huge discrepancy here all over. There's all these columns here, but here there's not. Those are futures. These columns are not the result of noise generation. These are, well, they might have noise in their creation, but them in themselves are not the result of the noise step, the surface step. They are futures that are pretty much like the last in the pipeline. Futures are the last in the pipeline. They are actually pretty early in the future pipeline, right? So, okay, so let's actually get to work, right? So if we look here at future lists, this is a list of all the futures in order. So the first one that gets executed is Basalt Pillar. Then we have surface structures, where we have three: the delta, the small basalt columns, and the large basalt columns. These are all part of the delta, the basalt delta. After that, we have underground decoration, which is the biggest. We have basalt blobs, blackstone blobs. We have the springs. We have patches, which we don't actually care about because we don't care about patches of fire for the Pathfinder. Although, if this is going to be open source, right? The code's going to be open source after I'm finished with the project. If you want to add that, like, feel free to submit a pull request. You know, this generator is being designed for this project, but I see no reason why it couldn't be expanded. So, if you know how to program Rust, and if you want to put in the time and effort of reverse engineering the source code, feel free to submit a pull request. Glowstone, that's actually not going to be that difficult. I've looked at it. It's pretty simple. And so this is all really nice, but there is one issue with features. If we go to the Java code with features, which, yeah, if we go to, what's it? Place with context? Not you. Here we go. What we do is we go through and we create a flat map. This is, just to be clear, this is lazy. I didn't realize this, and it caused me 3 days worth of headache, alright? Streams in Java are lazy. They are not eagerly evaluated, right? It's not actually evaluated until the for each loop, which it appears disappeared. What the fuck? Where'd it go? Did I accidentally remove it? The for loop should be here. Yeah, the for loop. No, it's... Oh, this is the same file. I need to go to the place feature class. Yeah. Yeah, for some reason, here, if I'll paste this here from the decompiled. For some reason, I got rid of the for loop. Whatever. So what it does is it goes through each one. You can imagine it like it does all these placement modifiers. Placement modifiers are checks to see if we can place... Why am I lagging? To see where we can place it, right? Where can we place the pillar? It does randomness, all this stuff. It does randomness, that's important. And then it generates the future. And then it moves on to the next of the same future. So it could generate like 10 of the same future. And then it goes through the first one, does the randomness to calculate it, places it, which consumes a lot of randomness, and then does the randomness to go to the next one, right? So the positions are computed as in the same random cycle as the other ones, as the actual placement logic. So that means one misstep in the futures can result in a catastrophic failure for every other future of that type. So we need a failure. If we go to, for example, glowstone, which no, I don't have that here. If we go to glowstone, can I not exit full screen? Okay. If I go to glowstone, we can see here that it checks if the block is netherrack, basalt, or blackstone. If we do this in the wrong order, or we have the biomes wrong, this can cause a cataclysmic effect on the rest of the glowstone features. Which is bad. Alright. This mouse, I love this mouse. I love the Logitech G35, but goddamn, its trigger keeps breaking and it's pissing me. I think I've compressed air, actually. Why don't you just throw some compressed air at it? Yeah. Sorry guys, I'm not actually in a bottom of this pit, so I'm gonna open this up and spray some compressed air in there. See if that did anything. It's called percussive maintenance, right? You're the slice of IntelliJ above me. That's not important. Whatever. Okay, that's good. That's good. I'm gonna put you up here. I'm gonna go get the slice of IntelliJ. Oh fuck! Scared the shit out of me. Where's IntelliJ? Oh, it's here. Alright, and what we're gonna do now is we're gonna go ahead and go to the Delta feature. And if we actually go, sorry, to the chunk generator, which is responsible for building the features. It's called build surface. No, not debug level source. What the hell would I want debug level source? Not build surface, I'm sorry. It's apply biome decoration. Yeah, and we can ignore a lot of this, but here is where it actually calls the place with biome check. It's basically, all we care about is that it's setting this random to a value in a fixed global table. I printed this using a mixin. That's the output here. And this tells us exactly where and when they are. And if we just get them in the right place in the enum, then it just works, right? So the random we know, and we have this verified because the pillars are correct, right? And they use that system. So we know that the randomness we're getting in, if we put them in the right order, will be a correct random source. This is printed directly from std out of Java. Yeah. Okay, so let's actually get to work. So we need to go ahead and add underground or surface structures. We need to go ahead and add this to the list of computable things. So we're gonna go ahead and see here. We have a lot of unused ones, which I just have them there because we need them to take up the slots. But we have undergrounded structures. Here, let me do, what was it, like dim.lsp.buff.rename? No, hold on. What was it? Then, oh, it's rename, oh my god. Wait. Vim.lsp.buff? That's the exact thing. Okay, dude. Does Kickstart have it? I'm using Kickstart for and boom. GRN. Good. Okay, so now we need to make this work. So we're in underground. I'll just verify that is underground structures. I have like shitty ass memory. Hold on, I'm guessing it's, yeah. It's surface structures. Underground structures doesn't have anything. Interesting. So yeah, it's surface structures. So you can see surface structures here. We can get the index from it, but it has an optional vector of features. And we can see here that get value. If we're trying to get it from surface structures, we're just outputting whatever data is in it. And so here is where we actually specify that data. So surface structures, we need to get rid of this none and give it a sum. And we're gonna give it a vector of future : and let's expand this vector. I don't like how I have to tab up like that. We're gonna do, so we need to go to the future here. We need to put surface structures, and we're gonna put a surface structure future. So let's go to, sorry, future surface structures. So we have, yeah, no, we don't want to do surface structure. We're going to do structure future. And I think we do have to include that then. this is what I don't like about Rust. Like, the using is like I used to use C++, right? Keyword used to, right? I'm not a loser anymore. But holy shit, I love crates. But you know what? Actually, I'm not even gonna complain. I retract what I just said. There's just gonna return to it. Wow, that's all key. Ball. Alright. So let's talk about some stuff that I have here. So chunk pause, that's the position of the chunk. Block pause, that's the position where it wants us to generate. Usually those are the same. Well, chunk pause is in chunk coordinates, but converted. RNG, that's the random source. So that's how we generate the random number. An accessor, this one's actually really interesting. So if we go to, how am I here? How did I get here? Oh my god, let's just go to world, that's where it's defined in. The transgeneration chunk accessor, before generation, sort of takes a snapshot of all the chunks that a chunk needs around it, and it saves those as read data. It clones them, unfortunately. It does clone them. That could be read from. And it also saves has a bunch of write chunks. Chunks that can be written to, and after generation, a post-process happens where the write chunks get written to, and the read chunks are thrown away because they're just there for the chunk to read. And it's not per chunk, it's per generation, so a generation is all sharing the same read data, so that would be ridiculous if they weren't. The cloning would be incredible. I did profile it. It didn't really, the cloning wasn't expensive. Like, it didn't show up on the profiler. It was mainly just the noise and stuff, so I'm not too worried about that. I'm sure the compiler's optimizing that anyway, which, you know, God praise the compiler. If we love you, I love you. And basically this lets you just get data. Like, you can read from it. You can get biomes. You can set a block. It's a read-write container split up into separate things. And of course, these are built using hashvects. A hashvec is my own custom data structure, which is a contiguous vector with indices hashed. So it's pretty cool. I had a lot of fun making this. I like making stuff like that, like little helper things. Those are sort of my favorite programs to make. Okay. Is my mic that low? Hello. I'll put it over here. Okay, so next we have to do delta. Delta, yes. So we need to figure out what requirements they have. So I think it's in Nether Futures. It's defined. Yeah, here. So they are a delta configuration feature. Lava. Okay, so these are. Okay, let's go to the delta because we need to figure out. So each feature has, if we go to the pillar, no, local modification, yes. They all have these placement modifiers. We need to figure out what the placement modifiers are for the delta. So we can just check the JSON file, to be completely honest. I love you, Sway. Okay. L2, nether generator. Why does that blop sound have to be so goddamn loud? Decomp raw, world gen, no data. Minecraft, world gen. Okay. And there is, I think it's in placed feature. Alright, and we need to, okay, delta. It does have delta. Yeah, here it is. Okay, so placement is count on every layer. Count 40. And the biome. Wow, so that's actually really simple. Wow. Okay. So we can go to surface structures. And we could say let placement modifiers, or we could just say modifiers, I guess, you know, saving precious word space. And I'm trying to remember how I did this. I really should, like, yeah, so I just make a vector of it. Okay, I guess that works. I could probably optimize this in a constant array at some point, but I don't really give a shit. Placement modifier : count layered, and it's just a constant of 10 of 40. Okay, so we need to do int provider : constant of 40. Maybe asking, why do I need a custom structure to represent 40? Well, we love you, Java. We love translating from Java. That's sort of what Java's all about, you know, classes and structures. And okay, to be fair, there are different types of ints that, like, it could use a random type of I don't know. Like, I'm just speaking words at this point. All right. All right. Modifiers. Now it's okay. So here's, I think, what am I doing with indentation at this point, bro? What is genuinely happening? Okay. Now we need to apply them. So we need a closure. So yeah, if we go to local features, there's a callback, which is a closure that happens per feature. So execute order placement modification does all the stuff, but it uses this as the function to call whenever it needs to do, you know, the stuff, right? So that's you've been informed about that now. So let's call it callback. It's going to take in pause, RNG, and accessor. Is it mutable? I don't need a special for the lifetime, I don't think. No, that's fine. Okay. And we need to do then placement modifiers : is it place modifiers? I guess we'll never know. It is. Thank you for not telling me. Thank you. I appreciate you for not telling me, Neovim. I appreciate it. You see, there's nothing. Do I not have it included? I do have it included. Okay, so it's just, oh, now it wants to show. Thank you. You know, you got there eventually. Accessor, pause, RNG. So the steps, we're just going to do modifiers. You know, we can actually just not even declare this as that. So we can say modifiers. This is just going to be a, actually, you could just do that automatically. Sorry, I forgot we're in goated Rust. Modifiers. And it's expecting a reference to it. Okay. Now we have to give it the closure, the callback. Expected reference. Oh. Okay. Expected bool found. Okay. I don't care. Okay. And we also have to add placement modifier : biome. Did I spell that right? Fire : biome. This is saying what biome can we spawn in. It's a hash set of biome ID. Wow, a hash set of biome ID. That was such a good idea. Why did I do that? That's actually so dumb. Whatever. I'll just do hash set : here. That's actually so stupid, but I'll do it for now. Let biomes equal hash set : new. Mutable. And we say biomes dot insert. And what biomes can, well, we know intuitively this is only going to happen in the basalt deltas, but there is a way we can actually do check that. So if we go to the nether biomes, this is where they're added. So we can see where they're added. We can see nether wastes, the futures, it is not given that, right? It's not given the delta. This isn't either. This is basalt deltas, right? This isn't, and this isn't. So we can see that is only the basalt delta. So we just want to say biome ID : basalt delta, and then we could go ahead and give it that. Oh god, I always forget. Sorry, whenever I used VS Code, I had prettier, which was like an auto formatter, so I'm just so used to not having to do semicolons and having to do even commas. It just did all that for me, really. I don't think it did commas, actually. Whatever. It is faster to format in Vim anyway, for me. Okay. So, callback, we're just going to do... We're going to do pub function delta place. This is pretty much going to be taking a lot of the same stuff, except for chunk pause. We literally do not need that at all. In fact, we don't need it like at all. So I don't even know why this function has it. This is going to output a bool. Now this bool value is actually not used, so I actually skip out on it, I think. Maybe later I'll globalize that. Missing type for oh, okay. I am LARPing Vim. That is what's happening. So, okay, now in here we need to call delta place with the pause, the RNG, and the accessor. Okay. Now, we have to actually do it. We have to actually do it. So let's go ahead and get this. I'm going to put it on my second monitor. You should still be able to see it, because it's like, yeah, it's on. I have it there, you know, where you can see it, right? Basically that is what's happening. So I'll make you bigger. All right. Okay, time to program. Actually, I need to make this bigger. All right, let's go to the delta future. So this is place, so we can see. All right, so we have to get a few constants I want to do first. This config, we don't need it, we just need the data it has. So rim size, so let's go ahead and define a constant. Is there a way to make a struct that just is a constant, like that doesn't, that I don't want to, I only want one of them to exist and it's just a constant? I don't think I can. You know what, I'll just define them inside the function. I think that's honestly not a bad idea. Alright, so we need to get some of these. So rim size, what's rim size? That's an int provider. Alright, okay, so what is that for you? So it's probably another, I think it's another features where that's defined. So there's two int providers. Rim size is the second one. So if we go, okay, so the second one was right. Real quick, I do want to go to placement provider or providers. We want to go to uniform. Right now I have them backwards, which is, it's fine. It is fine because I do also have them backwards in the other scripts, but I would really prefer to just have them the right way. Mim. Beautiful. Okay, now we need to go to local modification, just update that because it uses uniform here, and we literally just want to DD, not P. There we go. By the way, I love equal equals. Equal equals in Vim is so nice. Like if I just go up here and nope, that's not gonna work. I've learned my lesson. I can format it like that. It's so nice. Surface structures. So rim size is a uniform int. So let's go to nether features again. Uniform int dot of. That's not, I don't like that syntax, but we'll just do int provider is going to equal, I don't know if I can do this. Am I allowed to do that? I think I should be allowed to do this, right? Int provider is it not that? What is it? Wait, is it not an int provider? Is it a height provider? It is. So what is uniform int? That's different. Oh, these are different. So, okay, so we have to implement that for int provider, which actually doesn't look difficult. It's just a random between inclusive, which we have that implemented. So let's just go to int provider. Yeah. So we're just gonna do uniform. We have two i32s, and we're just gonna do int provider uniform. I cannot spell. Min max, right? And we're gonna output math ran. What is it? Ran between. Do I not? Yeah, create utils math. Do I not have it here? I don't. All right. Is it you trying to use raylib? I'm using create.utils math. I don't. Is it? It might be trying to use raylib. Yeah, like this is raylib. Vector 4. This is raylib. Okay, let me just specify. Yeah, I don't know why it was doing that. So it's. What did I call it? I know I have it. Oh, I think it might be in random source. Yeah. It's going to be, the random source is going to be specified in the sample. Yeah, okay. So we're just going to do RNG min max. And we want to, I know I did not just see vim lag. That's ridiculous. There we go. Okay, so now we have uniform. Now we can go to structure, what's it called? Surface structures thing. Yeah. This is going to equal int provider, uniform. And let's see, what does another have? 0.2. Expected bool. Yeah, well, I don't care. And now we need the other one, which is just size. So let's go to you. I know you are also uniform between 3 and 7. Cool. Now we have two other blocks. Magma. We actually don't have magma in the blocks yet, so we need to go to block. We need to add magma. Let's add it after gravel. That kind of makes sense. Then we need to match. For now, I'll just make self : magma color : from hex. We'll do the same as let's just do red. Brilliant. It's red. That's, yeah, okay. So contents and then rim. Okay. Contents is going to be block state. Block state, lava. And then rim is going to be magma. All right. Any other magic things that we need to get? With Manhattan. We need to implement with Manhattan. Alright. That's longer than I want it to be, but... What is Manhattan distance again? That's like just Euclidean distance squared, right? Metric needs to calculate the distance between 2 points in a grid. I don't know. I think sometimes. It returns an iterator of block pause. What the fuck's an abstract iterator? Oh. So we need to return an iterator that has neck. Okay, so yeah, we can do this. So we're gonna output impl iterator where item is equal to block pause. And we need to take in Is there a reference to this anywhere? It is. This dot cursor. So it takes other, so we need other pause. Then we have summed distance. Other x, other y, other z. This is a while loop, pretty much. Alright, I don't think I'm actually going to use an iterator here. I think I'm going to separate this into two things. What do you mean no uses? I see. Can I do an inline iterator? Oh, yeah. Yeah, you can. Oh, hell yeah. Wow, that's actually so nice. Yeah, you can. Okay, God bless Rust. So, std : from... let's go to here. We can use std : iter : from fn. So this literally lets you make an iterator from a function, which is super easy. Like, or a closure, in our case. But yeah, all right, let's do this. All right, so let's summed distance equal. We need to pass in other pause, which is a block pause, and I, J, and K, which could be fucking anything. I don't know why there's third positions. So maybe so real with you. And we say let other x equal other pause dot x. Let other y equal other pause dot y. Let other z equal other pause dot z. Now we need to return. This is what we need to do. So we need to set the closure. So let iterator equal. We're going to give it a closure. I'm going to do from fn on this closure. So we need to return, for example, none. This is now an iterator. And if I return none, then it's the end of the iteration. If I don't, then it keeps going. So it's literally just like implementing next. Alright, so let's go ahead and say let cursor equal block pause : new. Let current depth equal I need to find that out here. I can smell an issue with the borrow checker. It's coming in a second. Maybe not. I didn't create it. What am I doing? Cursor dot z equals other z, take away this for cursor dot z, take away other z. Yeah. We want to return the cursor. Some cursor. Else. What? Okay, hold on. We need to make this an option because it's doing some weird stuff. Okay. If y is greater than max y, x plus equals 1. If x is greater than max x, current depth plus equals 1. If current depth is greater than some distance, this dot end of data. Okay, then we want to return none. Guessing that's just what that means. Max x equals I dot min current depth x equals negative max x. Max y equals j dot min current depth take away x dot abs, and then y is going to equal negative max y. Let I x equal x, let jx equal y, let kx equal current depth, take away ix.abs, take away jx.abs. If kx is less than or equal to k, z mirror equals kx doesn't equal 0. Okay. Now we want to say cursor dot set, so cursor equals some block pause other x plus ix other y plus jx other z plus kx, and then we could say block pause x opt equals some cursor, or we could just say equals cursor because it's already an option. So we're to block pause found. Oh no, you should not be an option. What do you mean you can't find it in the scope? Function. Oh. Block pause x opt in this scope. Are you blind? It's right here. It's in scope. Pox. Alright. And then we want to return block pause x opt. Alright. That should be it. Alright, back to Delta Future. Our side project of Manhattan. Oh, distance Manhattan. Okay, well, that's actually easy. Alright. Okay. Finally. Okay. So we're gonna do wow, pretty was correct. Bool equal rand source colon next double RNG is less than 0.9. All right. Let rem sample x equal ternary. So I need to include that. And that's going to be random bool. And then if it's true, we want to do delta. We're going to sample it. So we want to do rim size dot sample with the RNG. Otherwise, 0. And then we could go here and replace it with z. Yeah. Say let rim bool equals random bool and rim sample x doesn't equal 0 and rim sample z doesn't equal 0. Alright, now we can do let size sample x equal size dot sample z. Alright, we can say let bigger sample equal size sample x dot max size sample z. Okay. Now we have a loop. I have to do for block pause in block pause. We want to do block pause or pause dot width. What was it? Dot distance Manhattan, I think. No, it was like width Manhattan or something. Hold on, let's go back. Oh. That's very likely JX. So it's just block pause like the actual struct. Alright, the pause are going to be block pause, that's just going to be pause. Size sample x, 0, and then size sample z. And we're going to go through them. Mismatch types, for loops, evaluate. Let me just put bool here so that it doesn't freak out. I fucking hate Rust Analyzer. Like the last 20 lines just get red if you don't return something. Like, bro, I'm gonna do it, man. I'm still in the process of making it. Just calm down, bro. Calm down. Ah. What the hell? Oh. So we want to do if man pause dot distance Manhattan block pause is greater than bigger sample, then we want to break. and we need to do is clear. So that, all right, so that's a helper function. So I'm gonna put it in here actually, and that sounds ridiculous. I love doing functions like in functions. It really clearly just shows like that it's associated. And is clear is only for this, right? So is clear is gonna take in a block pause. And that should be it actually. And it's gonna output a bool. So we need to do, we want to get the block of the position, so we're going to say, so we also need the accessor, right? So it uses like a level accessor. I use the trans generation chunk accessor. And do we set it? No, we just get it. So we need to just have an immutable reference. So we need to do let block state equals accessor dot get block. It's going to be block pause. So we need to do if block state dot is contents, right? So contents, that is the first one, so that's netherrack. So yeah, so if block state is equal to contents, then we want to return false. Then we do if cannot replace. So there's a, alright, so there's a table up here of blocks we can't replace. Let's make that. Blocks, : bedrock, block state, bedrock, block state, : nether bricks, block state, : nether brick stairs, block state, : nether brick fence, block state, : nether wart, yeah, and that's it for us. We don't need the rest. So we need to go ahead and go to block state and add those. So I'll add a comment. Fortress, nether brick fence, nether brick stairs, nether wart. And I'll add the spawner, but I'm not going to add the chest. One, two, three, four, five, six. Directions, okay. That's based off the order, so direction for it's gonna equal, I believe it's north, south, west, wow. North, south, down, up, north, south, west, east. Holy speedrunning. Who really needs a mutable reference for that? Yes, because it might need to insert. Yeah. Might need to make a chunk for that. Because that is clear. So for each of these, we have distance Manhattan. Okay, so we have to do if is clear man pause and accessor, then if rimbool then bl, what's bl? What is it referring to? Oh, it defines a random ass boolean at the very top. Okay. Why does it do that? And then at the end we return BL. That's it. That is the placement logic. Alright. I need to go to the bathroom. I'll be back. Okay. So, I think we're pretty much done. Right? Now I just have to make it place it, I think. Do I already do that? I do already do that. Expected bool. I was just gonna return true because it doesn't matter. Like, nothing uses this bool. Okay, do we have any errors? I think we do have one in block state because we didn't get the colors for the... Yeah. Alright, so I'm just gonna say anything that isn't here. I'm just gonna make color : : hot pink. Yes. Alright. No errors. Let's run it. Oh, wow. It's kind of hard to see. It looks like it's working. I can't... It looks promising. Okay, let's go ahead... Yeah, let's go ahead and compare this to Minecraft. It looks, at the very least, close. Right, is this... So ours has lava going here. I don't see that. Interesting. This is here. So these two blocks. Okay, this is very interesting. I can't tell if it worked or not. This is very... It's hard to tell because of the pillars, right? The pillars aren't making it very clear. It looks like this part generated pretty much right. But there's a lot more black stone there. Maybe it's doing something after. Okay, I'll double check just in case I did something wrong. I wouldn't be surprised, you know. Is there a better place to look? It's hard to tell. There is magma being placed. Is it being placed right? I can't tell. I genuinely can't tell. So this looks right. Yeah, so this right here looks right. And then above it, we have you. It sort of looks like... Okay, here's my theory. Like, the pillar... Is there a lava, like... No. Okay, so... I think something else might be happening. Real quick, let's just double check that we did everything right. Right, so we're going to go through it and just make sure that we did everything right. It looks promising. Down, up, north, south, east, west. I feel like I really can't tell if it worked or not. Like, this looks right. Okay, maybe it'll look better if we add the columns. So here it added a bunch of lava across here, which isn't there. I suspect that's because it might be using something called fiddle distance. We can go to the biome thing. I tried, when I was having an issue, I tried using fiddle distance, and I don't think I changed that back. Yeah, because we do get fiddled biome at, which replaces the just get biome at. See if this fixes that. That actually made it worse. How did that happen? Is next double implemented properly? That's our issue. So we use WorldGen random. We're using the Zero Shiro instead of the WorldGen. All right, that's simple. We just have to implement WorldGen's next double, because I thought like it looked right, but it looked wrong. Like it looked like it was the right algorithm, but it was using the wrong random. So you have to do if rng.is WorldGen abomination. And if you're not very clear, I do not like the WorldGen random system. I don't know if you could pick up on that subtle hint of dislike. It was pretty difficult to pick up on. I know you guys are stupid. The 0 people watching this, the absolute void I'm speaking to. Pipe. No, not you either. Right, the curly brace. So we need to do 0 Shiro world gen next double. So what's the difference I hear you saying is screaming right now? Well, I'll show you. Does it already have it? Because that makes things usable. No. So WorldGen random does weird. Like it's like kind of a LCG and a Zero Shiro. It's so weird. Alright, let me move my phone so I can read. Oh, that's it. That's all of it. Okay. So next double is going to be pretty simple for it. It's just that. So Let's do it right here. Alright, let's see if that fixed it. I don't really see much of a difference. I'm gonna be so free with you. Let's set you back to fiddled. That looked more correct. Alright, well, I think I'm going to end the stream here because I have a lot of debugging to do, I think. It looks like something with the random is wrong. I suspect maybe it's count on layer placement. I don't know. I'm not sure. But I'm going to end the stream here for now.